Okay, so I'm gonna talk through what happens, little part one of our demonstration of what happens when this attack um, is allowed to operate uninhibited. So, kind of the overall structure is we have one node here, worker 35, which will act as the communication server, which we'll call C2. This communication server uh, would connect with any infected nodes in the network that is open to the outside world um, to receive keys for encryption, acknowledge the existence of these infected nodes, and then send commands to these infected nodes whenever it wishes. Um, so for this server, this is just a simple implementation um, to just open up some sockets and then listen for that key, and then when we're ready, send the infected nodes the encrypt command. Um, so the encrypt command or the encrypting software, the actual ransomware, would typically be um, downloaded in the form of like a Trojan or something, or if it were like a targeted attack, it might be through the use of a vulnerability on a server or a machine. But generally, these like ransomware targets are generally Windows machines and servers, not Linux servers. So that's one small difference. Um, but how the encryptor works, I'll walk through it now. Um, Basically, so I don't brick the machine. I give it just a path to walk, which is our test file path, and then the type of file. Give it the file extensions that we want to encrypt. Um, so first, we're gonna generate the key for this infected machine, um, and then after that, we have the IP address of the host server, which is how CryptoWall, which this ransomware was based off of, was designed originally. It did not use domain generation algorithms to quickly spin up and shut down proxies to connect to the C2 server. So that's accurate in that sense. And we give it the port number, connect, and then we send the C2 server here our key that we're going to be using to encrypt. And then um, we're going to encrypt the files that we walk through in that folder. But before we do that, before we start encrypting, we want to attempt to propagate throughout the rest of the network. So this would have to either be done through some type of exploit, vulnerability, or privilege escalation, something like yeah, like privilege escalation, or being able to open a remote shell in the rest of the nodes in the network. But since that's not really important to demonstrate our mitigation solution, we're just going to go ahead and SCP the file. But just remember that in reality, you wouldn't be able to do this. So the ransomware would have to have some other way into these nodes. But after that, after we have all this set up, we're going to go ahead and start trying to connect to that C2 server once this encryptor is available on the infected machine. So it spins up, opens up a socket for us, and then attempts to connect to the C2 server to say, hello, I'm alive, I'm ready, and I'm willing to accept the commands that you give me. And then after we receive that command, we propagate and then attempt to start encrypting. So I'll kind of show how this works now, uninhibited. So this is a clean node um, for worker 76. So this encryptor file was from a previous experiment, so we'll show this is a clean file with a mitigation and detection on it without any of these modules running right now. So let's go ahead and start up the C2 server. And then So after this Trojan would get downloaded or added to this node somehow, it would get started up and spun up. So looks like we've connected with the C2 server. We have. So this is coming from our worker 39. We've established that connection. And then we're just, here's the key that we're using for encryption. So we would save this. So after a ransom would be paid, the C2 server would then send a decryptor to worker 39 for them to regain access to their files, or maybe not, just depends on the who is committing the ransomware attack. Never know. But okay, so it looks like it's waiting for us, and then we could just wait here for however long we wanted, and then when we're ready, we just send the encrypt command. And so it begins encrypting. So this is sent, we are self-propagating, sending this to another benign node. And if we look here in node 36, now we have another encryptor here on node 36 waiting to be activated. So we could look in our test encryption files. We just have some text files. So these should have been encrypted, and they have been. So your very important file 1 and file 2 text files are now requiring payment to get those back. These could be just anything, just depends on whatever I set the file extension to. And so this would be mitigated by our detection module and our mitigation application, which we'll show now. Justin or Jack, do you want to go ahead and start?
Yeah, so this will be the part 2 of our demo, and which will showcase the detection and mitigation module. So we had 2 server running in the backend. We had one zookeeper, which keep track of a list of node that is already affected, or I would say, yeah, that is already affected, and which we are going to do quarantine. And we also had a detection backend server, which will query the JSON file to ask whether if the current IP is a malicious node, which is in the block list. And currently, there's only one node, one IP address in the block list. So after we start our backend server, we'll first start the mitigation module at each node. So here we will start the mitigation module at node 36, and we'll also start our mitigation module at node 39, and we'll start our detection module right after it. So as you can see, we're waiting for an attack, and under the hood, there's a lot of traffic flowing through. So we'll wait for a few more like minutes for it to warm up. So at the same time, David will be preparing for an attack, and after he launches an attack, a function will be called, and the detection will be invoked, and it will propagate to the mitigation module, and it will quarantine the network. But before that, yeah, I think David, if you can start it, you could try to start it. I'm not sure if the network is blocked or not, because I haven't cleaned it.
Okay, hold on.
Or you could just, no. We'll have to restart it if it's not clean. Because it probably not.
Okay, let me start it up. Okay, so server started.
Yeah, so we had our attack, and as you can see, yeah, And yeah, and the watcher got invoked, so address, this address is blocked where David launches attack. And as you can see, it is also added to the block DB. Yeah,
And each one of those, 1, 2, and 3, so those are different Z nodes on each of our other nodes. So like 35
all
and
launched,
39,
yeah,
they each are
launched.
blocking them.
Right.
So that's why it's on there multiple times.
Yeah, so this is the demo of the detection and mitigation module. Yeah, and this is basically the basic layers of the mitigation detection module. We could like if there's for future work, we could definitely add more like more intelligent ways of detecting, yeah, and mitigating. So right now it's more like hard coding it, yeah, but it's working on a distributed system, so we're kind of satisfied with the result. Yeah.
Yeah, and like this method, like using a blockless DB, it's still relevant, like it's still used today, but for ransomware that uses domain generation, it doesn't work against, but since ours is based off of crypto wall, that's why it works. So some ransomware it works, but like some like say more modern ransomware that's released like this year, probably this would not work against it unless you had an actively maintained blockless DB, which you can get like IPS services, they provide them, but it's rare that they're maintained well. And yeah, if you have something with DGA, then it just doesn't work at all. So it applies to a very specific subset of ransomware. Yeah.
Right, thanks.